For n greater than 2, let Kn be the product 5, 10, 17, 26, so on and so forth until n square plus 1. And let Sn be 1 minus 1 by 2 to the power 4 multiplied by 1 minus 1 by 3 to the power 4. Like this it will go on until 1 minus 1 divided by n to the power 4. Then what is Sn divided by Kn? This is a multiple choice question and we have to choose one of the following answers. Answer A is 1 by 2 multiplied by 1 divided by factorial n squared multiplied by 1 plus 1 by n. Choice B is 1 divided by Kn multiplied by n square divided by n plus 1. Choice C is n to the power of 4 plus 1 divided by 2n plus 2 whole multiplied by 1 divided by factorial n. The fourth choice is 1 divided by Kn multiplied by 1 divided by n by 4 multiplied by 1 divided by n minus 1 factorial to the power 4. And the last choice is E, which is none of the above. Now, Sn is equal to 1 minus 1 by 2 to the power of 4 multiplied by 1 minus 1 by 3 to the power of 4, and the multiplication will go on until 1 minus 1 divided by 1 by n to the power of 4. Now we know from elementary algebra that x plus y, or rather 1 plus x multiplied by 1 minus x is equal to 1 minus x square. Therefore, we can always write 1 minus 1 by 2 to the power of 4 is equal to 1 minus 1 by 2 to the power of 4 multiplied by 1 plus 1 by 2 to the power of 4. That is, we are speaking about this term. Similarly, the next term 1 minus 1 by 3 to the power of 4 can be written as 1 minus 1 by 3 squared multiplied by 1 plus 1 by 3 squared. We can do this for all the terms of Sn, and then we get, for each of these terms we get two terms, that is 1 minus 1 by 2 to the power of 4 is equal to 1 minus 1 by 2 to the power of 2 multiplied by 1 plus 1 by 2 squared. And the second term becomes 1 minus 1 by 3 to the power of 2 multiplied by 1 plus 3 to the power of 2. And this will go on until the last term becomes 1 minus 1 by n square multiplied by 1 plus 1 by n square. Now, look at this term. If we simplify that, that becomes 5 by 4. Look at this term. If we simplify that, that becomes 10 by 9. Look at this term. If we simplify that, that becomes n square plus 1 divided by n squared. So, Sn becomes this expression. And we know the value of Kn given in the question is 1 multiplied by 5 multiplied by 10. Like this it will go on until n square plus 1. Therefore, Sn by Kn is this term divided by this term. Now, if you look at the numerator and denominator of this right hand side, we see that there is a 5 here which will cancel with this 5. There is a 10 here which will cancel with this. Similarly, there will be a 17 here which will cancel with 17. There will be a 26 here which will cancel with 26. And there is a n square plus 1 here which will cancel with n square plus 1. So, we will be left with all these minus terms 1 minus 1 by 2 squared multiplied by, from this term only 1 by 4 will remain. Then this term will remain as it is, that is 1 minus 1 by 3 squared, and from this term only 1 by 9 will remain. Like this it will continue, and the final term will become 1 minus 1 by n squared multiplied by 1 by n squared. Now, if we recognize that 1 by 4 is equal to 1 by 2 square, 1 by 9 is equal to 1 by 3 square. Like this, last term is 1 by n square. So, we take these square terms together, that is 1 by 2 square multiplied by 1 by 3 square multiplied by 1 by 4 square, etc. until 1 by n square, and the remaining terms are 1 minus 1 by 2 square, 1 minus 1 by 3 square, 1 minus 1 by n square. So, Sn by Kn becomes this term. Only we have rearranged the right hand side. So, in formula term, we can write this as 1 by 2 multiplied by 1 by 3 multiplied by 1 by n whole squared, and this becomes 1 divided by 1 by factorial n whole square. Why? Factorial n is equal to, rather factorial n is equal to 1 multiplied by 2 multiplied by 3. Like this it will go on until n. So, 1 by factorial n is equal to 1 by 1 multiplied by 2 multiplied by 3 multiplied by 4. Like this factorial, like this it will go up to n. So, 1 by factorial n square is equal to 1 divided by 1 multiplied by 2 multiplied by 3, like this until n whole squared. And that is what we have here. So, we get Sn by Kn is equal to 1 by factorial n square, and finally we 1 by 1 minus 2 square, we segregate that into two terms, 1 minus half multiplied by 1 plus half. Similarly, this will become 1 minus half multiplied by, 1 minus 1 by 3 multiplied by 1 plus 1 by 3, and the last term will become 1 minus 1 by n multiplied by 1 plus 1 by n. And that becomes half. This first term becomes half, second term becomes 3 by 2, third term becomes 2 by 3, fourth term becomes 4 by 3. Like this it will go on. And if we write this out, we get Sn by Kn is equal to 1 divided by factorial n whole square multiplied by half into 3 by 2 multiplied by 2 by 3 multiplied by 4 by 3, etc. Finally multiplied by n minus 1 by n multiplied by 1 plus n. So, these 3 will cancel with these 3, these 2 will cancel with these 2, these 4 will cancel with this 4 somewhere, 3 will cancel out. Finally, we will be left with 1 plus 1 by n. So, Sn by Kn will become this half multiplied by 1 divided by factorial n whole square multiplied by 1 plus 1 by n. And that is option A. Thank you. Please like, subscribe, share and hit the bell so you can be immediately notified for new uploads. It is completely free and only takes a few seconds, and you can always unsubscribe later. But it encourages me to solve, record and upload more such videos which might help you in math computations. Thank you.